Thanks everyone for joining today's OpenJ9 community hangout. In particular, we're very lucky to have Ashutosh with us today to talk about idle detection. So Ashu, if you want to take over screen sharing and launch into your lightning talk.
Am I audible?
Yes.
Okay. So, are the slides visible now?
Yes.
Okay. So I'll start off now. So hello everyone. I am Ashutosh Mehra, and I have been part of J9 VM team and now OpenJ9 project. I'm working with OpenJ9 project as a contributor, and last year we added a feature related to idle tuning in OpenJ9. So basically, we try to reduce the memory footprint of OpenJ9 when the application is in idle state. So why do we need to do this? Why do we need to tune OpenJ9 during idle phase? The reason or the use case comes from the cloud environment, which is being used for deploying applications these days. So different cloud vendors have different pricing models, and if your cloud vendor is using consumption-based pricing model and using memory as the resource for charging you, as an example, like how much memory you are consuming in a day or per hour, if that's the criteria for charging, then obviously you would need your application's memory footprint to be as low as possible, and you would want it to be low not only during active cycle when your application is servicing the request, but also when there's no load on the application. So with this context, what action the JVM needs to take? If in JVM we know that heap is the largest consumer of memory. So I have depicted the heap state during active and idle cycle in this slide. So on the left hand side is the active, the heap state in the active state in the active phase. So you have
Ashu, we're still seeing the title slide.
Okay, I'll wait for a few seconds. I have moved to second slide.
We're seeing the whole. There we go.
No, okay.
Perfect, that worked. We see the slide 3 now.
Okay, I think if I go into slide mode, is it appearing in the?
No, we're seeing the whole.
Okay.
The presenter view, not the.
Probably I should start the slideshow and then share my screen. Or
that's looking.
Are you seeing the title slide?
Yeah.
Okay. So is it moving now?
Yeah. Thanks, Ashu.
Okay. So yeah. So in this slide, I'm depicting the heap state during active and idle cycle. So during active state, you can see there's a XMX value, which is your maximum size your heap can expand up to. So at any given point in time, your JVM would have reserved some amount of space. Reserve means this much heap memory is actually backed by a physical page. So then there's then your JVM at any point in time will be using some amount of heap memory for allocating objects. That is indicated by the green bar, which indicates the current usage of your application. So now, if your application goes from active state to idle, say it has completed some transactions in the active state, and now there is no load on the application, it goes into idle state. So in the idle state, you will find that many of the objects have become garbage. There are no references to those objects. They were used during the transactions earlier, but are not anymore live. So there is a certain section of the heap which has turned into garbage, but the GVM is not collecting that memory because it doesn't have any memory pressure to run a GC cycle. So that garbage sits in your heap and keeps your memory footprint bloated. If you can collect that garbage and decommit the memory. Decommit means return the memory back to the OS, with that's the state which is indicated in the last diagram, which has the heading of idle tuning. You can see the large part of the heap we are able to decommit if we do a GC cycle. So that will also reduce the memory footprint of your application. So this is the tuning that we have done in OpenJ9. So coming to OpenJ9 implementation, there are two steps to idle tuning. The first is identifying the idle state of your application. So OpenJ9 already had a notion of idleness, idle state, thanks to the JIT sampler thread. So the sampler thread is a native thread which samples the JVM at a predetermined frequency. It collects some statistics related to CPU consumption, memory, class loading state, JIT state. Along with that, it also determines whether there are any active threads or not. And based on this based on the active threads, it changes its state. So the flowchart you're seeing on the slide shows a very simple view of how the sampler thread states change. So it starts in the default state, which is nothing but an active state. During this state, it sets its frequency or the sampling frequency to 10 milliseconds. That means it wakes up every 10 milliseconds, performs some, collects some samples, determines whether there are any active threads or not, and then goes back to sleep. So in active state, if it detects there is no activity, there are no active threads for 5 seconds, then it changes state to idle. In idle state, it also changes its sampling frequency to 1 second. Since the application is idle, it doesn't make sense to sample the application that frequently. So it increases the sampling frequency to 1 second. If it continues in idle state for another 50 seconds, then it changes state to deep idle. And in deep idle, the sampling frequency is set to 100 seconds. So to determine whether the VM has gone into idle or not, we rely on JIT sampler's state logic. And we say that if sampler thread continues to be in deep idle for some specific amount of time, then we declare the VM as idle. So at that time, the sampler thread will send a notification to the idle to the VM to change its state to idle state. Now, the amount of time that the VM can wait to declare itself as idle can be configured using -XX: idle tuning min idle wait time option. Now, since we are relying on sampler thread state logic to declare VM as idle, it has two implications. First is you can see from the flowchart, it takes around 55 seconds for the sampler thread to go into deep idle. And unless the sampler thread has gone into deep idle, we don't declare the VM as idle. So to declare VM as idle, it will take minimum of 55 seconds. And second implication is since we are tied to sampler thread state logic, and sampler thread has to send a notification to a VM. That means the VM can be declared idle only at discrete points in time. This is because when sampler thread is in deep idle, it wakes up every 100 seconds. So once it goes when it wakes up at that point, only it can declare the VM as idle if the min idle wait time has elapsed at that particular point. So this is in short about the uh, logic that we use for identifying the idle state of the VM. If you want to know whether your VM has gone into idle state or not, you can actually enable JIT logs. So to enable JIT logs, you can use -x JIT verbose with compile performance as the sub option. This JIT logs will contain a lot of compilation related information, which methods are being compiled and all. In addition to that, this particular option also causes sampler thread to emit messages when it changes its state. So I have put up a snippet of the JIT logs for an application which has gone into idle state. So you can see the first message, which is in red font. It says that the sampling thread has gone into idle state and its frequency has changed to 1 second. That happened at t equals to 17 seconds. So the time given time in front of t is in milliseconds. So if you convert it, it comes to around 17 seconds. Followed that, there are a couple of compilation related information, and after that, at time 67 second, you see that there are two messages. So the sampling thread has actually changed its state to deep idle, and at the same time it also notified the VM to change its state to idle. So that number 2 indicates that the VM state has been changed to idle. So in a sense, if you want to determine whether your VM is running in idle state or not, you can enable JIT logs and look for this particular statement sampling thread changed VM state to 2. So once the VM has gone into idle, now it has to take action to reduce its heap, reduce its heap memory, that is decommit the heap memory. And that behavior is governed by two options. The first is -x idle tuning GC on idle, and the other is compact on idle. So in both cases, the VM will optionally do a GC when it gets a notification from the sampler thread that it has gone into idle state. So at that time, it may do a GC, and then it will decommit the free pages in the heap. So the condition that governs whether JVM will do a GC or not is actually depends on amount of memory that has been allocated in tenure space since the last GC cycle. So in 0.9 release of OpenJ9, this value is actually 40%. That means if 40% of the tenure heap memory has been allocated since last GC, the JVM will trigger a GC cycle when it goes into idle phase. And after completing the GC, it will decommit the freed heap memory. This is likely to change in the future release, as there is some discussion on whether to enable GC unconditionally or not. The difference between compact on idle and GC on idle is that that in compact on idle, the JVM will do GC as well as compaction. So there is likely more memory available to decommit because of compaction. Now these two options, you can check the behavior of these two options in GC logs. So if you enable GC logs using -verbose :GC or -x verbose GC log, and the JVM performs a GC during idle phase, you will see a GC cycle which has a reason equals to VM idle. So if you observe in GC logs, there is a GC cycle which has the reason as VM idle. That particular GC cycle has happened in idle phase. And similarly, when JVM decommits memory, it emits a heap resize tag in the GC log, which has type as release free pages and reason as idle. This tag also has a field called amount, which is supposed to indicate how much memory has been decommitted. But this information is currently inaccurate because we are not keeping track of, uh, of of which free pages are actually backed by physical page or not. This information is not correct. If we want to observe, if we want to measure how much memory footprint has gone down by due to idle tuning, then I would suggest to observe the resident set size of your process. On Linux, we can do that using top. So if the resident memory of your process goes down, then I mean it should go down during this idle tuning when the heap resize message is emitted in the GC log. During that time, you should observe your resident memory going down. So yeah, that covers the OpenJ9 implementation. The next slide talks about the options related to idle tuning, which most of them I've already covered. The only one which I've mentioned is idle tuning min free heap. This option tells the JVM how much percentage of memory it should not decommit out of the free heap. So if you set min free heap on idle to say 20, that would mean out of total free heap available to decommit, it will not decommit 20% of the memory of the free heap. So 80% of it will be decommitted. As of now, the default value is 0. That means it decommits everything. And from Java 9 onwards, we have enabled GC on idle with Xtune virtualized. So if you set Xtune virtualized, which we generally recommend for cloud deployments, then GC on idle will get enabled by default. Few more points related to idle tuning. First of all, it is supported only on GenCon policy as of now. And in GenCon also, we are actually decommitting memory only on the tenure space. So GenCon has two memory spaces, nursery space and tenure. Tenure is the one which corresponds to long living objects, and that's the one which we decommit during idle phase. We enabled this enable support for idle tuning on Linux x86 initially, but this year we have also enabled it on Linux, on all supported Linux platforms, Power, Intel, and Z-Linux, and also enabled it on ZOS. And with the 0.9 release of OpenJ9, the Docker images which we can obtain from hub.docker.com under adopt OpenJDK, the idle tuning options are already set. So you don't need to set these idle tuning options specifically if you are using Docker images. I think that's all I have.
Thanks, Ashu. Does anybody have any questions? So I have one. Ashu, why do we only decommit from tenure?
So I'm not sure of actual reason why we actually did it. I'm not aware of that, but all I can think of at this moment is probably nursery space, something which is very active, since most of the allocations happen during in the nursery region. And if we decommit from the nursery region, and when the application comes back into active state, it will suffer more page faults. So when we move back to active state, it may likely impact the performance a bit. That's the only thing that I can think of at this moment.
Okay, that makes sense. Does anyone else have any questions for Ashu?
Just a quick one, and maybe I'm asking the wrong person, but we added a idle micro benchmark that is being run at Adopt OpenJDK right now. Do you know what that benchmark actually shows? Were you part of the team that actually wrote that benchmark, Ashu?
So yeah, I was involved in that
Yeah.
in those discussions, and as far as I recollect, it used to it allocate. It's a simple benchmark. It's a simple program which allocates memory and tries to allocate memory in the tenure space, large objects which go into tenure space, and then it goes into idle state and waits for the for this idle tuning feature to kick in. Uh, and at the same time, we are also measuring or monitoring the top output, and we ensure that when idle kicks in, we see a drop in the resident memory of the process. So I think
Yeah, that
all.
sounds like what I'm seeing that's happening. Thank you. So I guess if I wanted to be more proactive in monitoring that, I should check whether or not the as we continue to take on new builds, I should be monitoring some of those results for if they drop below a certain expected threshold.
Isn't the benchmark doing that already, or I didn't actually get
I
that
guess
far.
it is.
Okay, so
Yeah.
you are
Okay.
referring
Well,
to.
I'll take it offline.
Okay.
I can.
Okay.
Thanks.
It may be, Shelley, that the tests that are there are more functional in nature than performance, just making sure that all the events happen and that as expected, rather than actually trying to do a load of measurements. I'm trying to remember, it was Tanvi who checked him in, but I'm not sure she's with us anymore.
Mm-hmm. Yeah, I'm going to take a closer look because now that I understand the feature better, thanks to Ashutosh's lightning talk, I can make sure we're taking advantage.
Okay. Are there any other questions? All right, then thank you very much, Ashu. And
Thanks, Dan. I
really
will drop off from the call.
Okay. I just want to say we really appreciated having you come and talk about this feature.
Pleasure is mine.
Are there any other user-related or community-related discussions we should have at this point in time? Okay. Then I think we should jump into the usual business. Irina, have you had a chance to update the queries?
Yeah. So 1 second to get to my screen. So okay. So for today, if we look August 22 versus August 15, we have only 4 extra issues. One of them is in the docs. The nice thing is if you look at the usual, the usual contributors, that like the biggest, I find JIT and VM, they are together. They make for half of the issues that they are down, right? So the other thing is I'm missing 3 issues. I don't know where they are spread. So every single component that we're tracking here is down, but I have 3 issues that I need to chase to find where they are. So long story short, small increase, good decrease small increase overall, good decrease on a couple of components. So that would be for the issues, and it's a similar story for the PRs. So we went from 95 to 98, so 3 totals, and if you see both the JIT and VMs are down, so I'll chase the other one. So we're not different than overall, not different than where we used to be. Very, very small increase. But small decrease in components. Any specific questions? Yes, no, so back to you.
All right. Thanks, Serena. All right. Just a reminder to every component to please make sure that you're tagging issues and PRs appropriately, and that we're adding the beginner tag to help anybody new who might be joining the community to find pieces of code to start with. All right. Taking a look at the machines. Do we have an update on the machines that are being moved to UNB? So there's an action item for me to confirm whether the power was just PPC-LE or AIX as well. And I can confirm that that is only PPC-LE. I know we're targeting, we had been targeting the end of this month to get the machines moved. I'm not sure we're going to make that date.
Sorry, I was just asking Joe. He says the machine should be being shipped today.
Oh, excellent. That's a great step forward.
Mm-hmm. So I guess the paperwork was signed.
That's great to hear. And then do we know when they would likely be online at UNB?
Not sure. We'd have, depends when Charlie goes, I guess. And yeah.
Okay.
Not sure how long it takes to set them up.
Just have to encourage Charlie to fly out there. All right. It's good to hear.
If Charlie's there, we can give an accurate.
Depend on Charlie's skills.
All right. Are there any other machine configuration or machine issues we should be talking about today? All right. In terms of Mac OS, I have some patches. The story continues to be I have some patches that I need to clean up. In some of my cleaning up, I've broken some of them, so I have to figure out what I've done to them. And that'll get us to the point where we can start to load DLLs, and then there's more work to fix the load paths and figure out exactly where things are going wrong. In terms of ZOS, is there any update there? Okay.
Right, lost my mute button. Only that we are still working through all the JT-Reg test issues as we find them. Bill's still going on internally here. And again, I'm afraid, still a way to go yet.
Okay. In terms of ARM32 and 64, is anyone aware of the current status there? All right, and we'll skip along as I'm cognizant that we're down to our last 8 minutes before Zoom will kick us off. So end user experience, are there any issues in this particular area that we should be discussing? All right. Then we'll skip past that today as well. The 0.9 release is complete, which is good to hear. The next step here is to follow up with the SDK. SDK Man, I believe, is the product or the tool to install SDKs. They've opened an issue with us to see about getting OpenJ9 releases staged in our tool. All right. Is there any other business that we should discuss today? I have a proposal that's half written to talk about the release schedule, but I'll wait until I finish getting that written up and then send it out on the mailing list for more discussion there. All right. If there's no other discussion today, then thank you to everyone for attending, and we'll meet again in a week.
Thanks, Dan.
Thanks, bye.